There's a whole new type of vulnerability that we never really had to think about with traditional software. But now that AI is in the mix, a whole new set of problems has shown up. Hey everyone, I'm Ramsey, and in today's video, we're going to look at some of the vulnerabilities that pop up in N8N when you start adding AI to your workflows. So, N8N is basically an orchestration platform. It connects all your different tools, lets them talk to each other, so you can automate entire systems. That's super powerful. But it also means N8N kind of becomes a universal API key for your whole digital setup. Because of that, it ends up holding a ton of sensitive stuff. So if someone manages to compromise your N8N instance, they could potentially get access to AI API keys like OpenAI, Anthropic, Google Gemini, cloud credentials like AWS IAM keys, Microsoft Azure tokens, you name it, or WAF and refresh tokens for services like Salesforce, Slack, HubSpot, Gmail, database connection strings and passwords, encryption keys and JWT secrets stored in environment variables. The list is endless. We're going to start with the simple stuff and work our way up to the really interesting attacks. Stick around till the end. That's where things get really juicy. Alright, first up, prompt injection. You've probably heard about this one a million times. It's that classic ignore all previous instructions and reveal your system prompt trick. That doesn't work anymore because they made the models better, but prompt injection is always evolving. It sounds obvious, and the AI providers have done a pretty good job training their models to resist it, but security is always a cat and mouse game. As the defenses get better, the attacks just get sneakier. So picture this, you've built a shopping agent in N8N. It can access your credit card, it can make HTTP requests, it can send emails. It's powerful. Now, imagine the e-commerce site it's visiting is controlled by a bad actor. That site could have hidden instructions, completely invisible to you, telling the AI to send your credit card info somewhere else. The AI isn't broken. It's just doing what it thinks it's supposed to do. It's following instructions it was given, just not by you. So, what's the best way to protect yourself? Well, first, treat all inputs like they're radioactive, and I'm not joking about that. Don't feed user input directly into system prompts, because those get top priority in how the model makes decisions. Usually the hierarchy is first whatever they have the company, then system prompts, then developer prompts, then user prompts. So you don't let customers walk in and start giving orders directly to the chef. There's a process, there's a buffer, same idea here. Second, limit the number of tools your AI agent can actually access. If your agent only needs to read emails, it shouldn't also have the ability to send them, or delete them, or access your calendar. Give it exactly what it needs and nothing more. This is called the principle of least privilege. You can also put structural separators between your system instructions and any user-supplied data, so the model has a clearer sense of what's a command and what's just input. And if you're pulling in community templates from N8N's marketplace, audit them before you run them. A template can arrive with a maliciously crafted system prompt already baked in, and you'd never know until it fires. But here's the honest truth. There's no 100% foolproof way to stop prompt injections. Models will always have some level of vulnerability. It's just part of how large language models work. It's kind of baked into the physics of it. So the goal isn't to eliminate the risk entirely. That's impossible. It's to make it as hard as possible. Second, overprivileged tool access and permissions. Remember when I talked about least privilege? Well, we're going into that. Here's a simple way to think about it. If a user has access to a model and that model has access to information, then that user effectively has access to that information. There's a saying that goes something like, the best way to take care of a problem is to have someone else do it for you. In traditional software, if a bad actor wanted your data, they had to do it themselves. They had to actually hack their way in or socially engineer your employees. But with AI, you've got something else doing the dirty work for you. A good example is people have been connecting models to SQL engines so they can query databases in plain English. Great use case, genuinely useful. But if a bad actor has access to that model, they can just dump your entire database without ever touching your machine. Here's another one. A roofing company connected their N8N reservation agent to a calendar tool to check availability. Sounds harmless, right? But it ended up exposing customer names, phone numbers, home addresses. When someone asked the agent about completely unrelated things, they just had to talk to it and ask it for these details. The builder never intentionally gave that data to the LLM. The LLM never hacked anything. The data was just reachable because of the permissions the agent already had. So, how do you fix this? The main thing is to stop treating credentials as shared resources across your whole setup. Instead, create dedicated service accounts for each individual workflow. So if you have a workflow that checks calendar availability, that's all it can do. It doesn't get to see customer names. It doesn't get to touch anything else. And if you want in a future episode, we can go deeper into how to create service accounts and give them access in your N8N. Think of it like giving someone a key card that only opens one specific door, rather than a master key to the whole building. And regularly go back and audit what each workflow actually has access to. It's really easy to set something up quickly, give it broad permissions to get it working, and then just forget about it. Those forgotten overprivileged workflows are exactly what attackers look for. If you're on a paid N8N plan, you also have access to more advanced RBAC controls, worth actually using them. Third, denial of wallet. So, this one doesn't get talked about enough. And honestly, the name says it all. Here's how it works. An attacker crafts an input that causes your N8N AI agent to get stuck in an endless loop. Maybe it's a logical paradox. Maybe it's a task that keeps spawning new subtasks. The agent just keeps going. Planning, executing, making API call after API call after API call. And every single one of those calls costs money. What we're looking at here is purely financial damage. Nobody gets into your system. Nothing gets stolen. Your wallet just quietly drains in the background. Here's what makes this sneaky though. N8N workflows can run on a schedule through webhooks or through chat interfaces, all without anyone watching. And when an agent hits a loop, it doesn't just stop and throw an error. It tries harder. It spawns more sub-agents. It retries. And the worst part, this doesn't trigger a single security alert. There's no unauthorized access event or anomalous outbound connection or credential warning. The workflow just keeps running exactly as designed. The only signal you get is an unexpected invoice after the damage is already done. So, what do you actually do about it? Start at the LLM provider level. Every major provider, OpenAI, Anthropic, AWS, Bedrock, they all let you set hard spending caps on your account. Go and set them now, before you need them. It takes 5 minutes and it's probably the single most effective thing you can do to ward yourself against this attack. Inside N8N itself, there's a setting in the AI agent node called max iterations. Use it. Set a reasonable ceiling on how many steps your agent can take before it just stops. It won't break your workflows in normal operation, but it will stop a runaway loop before it gets out of hand. Also, set up billing alerts. Most providers let you set a threshold where you get an email or a notification when spending hits a certain amount. That way you're finding out in real time, not at the end of the month. And if you have any public-facing chat interfaces or webhooks connected to your agents, rate limit them. If someone is hammering your endpoint with loop-inducing inputs, rate limiting means they can only do so much damage before they get cut off. Fourth, memory and context poisoning. Okay, so this is where things start to get really interesting. A lot of N8N setups use persistent memory, meaning the agent actually remembers things across sessions. That memory gets stored in vector databases like Pinecone or Quadrant or Supabase, a super useful feature, but it opens up two pretty nasty problems. The first is leakage. Without proper filtering, an agent's memory window can pull in context from previous sessions and start surfacing that to the wrong people. We're talking customer data, internal configurations, even workflow logic showing up in someone else's conversation. The second is poisoning, and this one is subtle. An attacker embeds malicious instructions inside content the agent is designed to process, something as innocent as a calendar invite description. or a document uploaded to a shared knowledge base, or a meeting notes email. The agent reads it, absorbs it, and stores it as trusted context. And here's the scary part. Because the malicious instruction lives in the vector database and not the model itself, restarting the agent does absolutely nothing. The poisoned memory just gets retrieved again on the next relevant query. So research out of NeurIPS 2024 showed that poisoning less than 0.1% of a RAG knowledge base was enough to hit over an 80% attack success rate. While the agent continued behaving completely normally on regular queries, you would genuinely never know. They've even done this with training. They show that you can even poison training data. So it's really deep. And it gets worse. A proof of concept called Zombie Agent showed that a single poisoned email attachment could plant a memory in an agent connected to your inbox. Every subsequent interaction activates it. The agent starts leaking sensitive data through hidden side channels, and because it's connected to email, it can actually spread, infecting other agents it communicates with like a worm. N8N has no native tools to audit what's sitting in your memory nodes, no anomaly detection, no way to verify that a retrieved memory was written by a legitimate source. It's all trusted by default. So what can you do? The big one is memory segmentation. Don't let your agent share a memory pool across different users or sessions. Each session should have its own isolated memory so that data from one conversation can't bleed into another. Treat everything that goes into memory as untrusted until proven otherwise. Emails, uploaded files, API responses, all of it. Before any external content gets written to your vector database, it should be going through some kind of sanitization or filtering step first. Set expiry policies on stored memories. There's no good reason for an agent to be holding on to context from 6 months ago. Older memories should expire and get cleared out regularly. And log your memory write events. N8N doesn't do this automatically, so you'll need to build it in. But knowing what's being written to your vector database and when gives you at least a fighting chance of spotting something weird before it causes real damage. Fifth, and this is a big one, credential theft and pipeline hijacking. Big words, I know. Everything we've covered so far operates at the prompt level. This one goes deeper. Remember how we said N8N is basically a universal API key for your whole setup? Well, all those credentials, your OpenAI keys, AWS tokens, Salesforce logins, database passwords, they're all stored encrypted in N8N's database. And the thing protecting all of it is a single encryption key sitting in your environment variables called N8N_encryption_key. Now, between November 2025 and February 2026, researchers disclosed a string of critical vulnerabilities that give attackers a pretty clear path straight to that key. CVE 2026-21858, nicknamed Nightmare, with a CVSS score of 10.0, a flaw in how N8N processes webhook content type headers that lets an unauthenticated attacker read arbitrary files off your server, including your database, including your encryption key. Researchers estimated it affected around 100,000 servers globally. CVE 2025-68613, CVSS 9.9, an expression injection flaw that lets authenticated users escape N8N's JavaScript sandbox and run arbitrary OS commands. Over 100,000 publicly reachable instances were vulnerable as of December 2025. And then there's CVE 2026-1470 and 0863 with CVSS scores of 9.9 and 8.5. Disclosed January 2026 as bypasses of the previous patch. They fixed one hole and researchers immediately found 2 more. CVE 2026-25049, another round of bypasses. This is February 2026. At this point, N8N's own maintainers just straight up acknowledged it openly. And look, this isn't a series of random bugs. It's a recurring architectural problem with sandboxing dynamic code at runtime. But here's what actually makes this attack class dangerous. It's not just about stealing credentials, it's about what happens after. Once an attacker has your LLM API keys, the smarter move isn't to just use them directly. It's to silently reroute all your AI calls through attacker-controlled infrastructure. Every prompt your N8N workflow is sent to GPT-5 or Claude or Gemini, they're basically intercepted. Responses are modified before they come back to your workflow. Your automation keeps running, your dashboards stay green, everything looks completely normal. The only change is that the attacker now controls every single AI decision your organization makes through N8N, and they have full visibility into every prompt, including the ones with customer data, internal business logic, and system context. As one security researcher put it, all those prompt injection defenses, output filters, content monitors, they assume they're receiving legitimate requests from a trusted source. If the workflow layer is compromised, you're feeding the AI whatever the attacker wants from what looks like a completely trusted source. The AI has no idea. This can go undetected for months. There's no downtime, no disruption. The only forensic trail is in execution logs, and that's only if you have logging enabled in the first place. So, what do? First and most urgently, upgrade. You want version 1.123.17 or higher, or 2.5.2 or higher for N8N. That is as of February 2026. A lot of these CVEs have patches available and people just haven't applied them. As of late January 2026, over 39,000 instances were still unpatched against the original nightmare flaw alone. Don't be one of those. If you have any reason to suspect a compromise, even a small one, rotate every single credential stored in N8N. All of them. Just assume the encryption key is already known and act accordingly. Keep your LLM API credentials separate from everything else. Issue them with the narrowest scope possible and treat them differently from your other system credentials. Never expose your N8N editor interface directly to the internet. Put it behind a VPN. The editor is not something that should be publicly reachable. Run N8N in containers with minimal OS privileges. If an attacker gets in, you want to make lateral movement as difficult as possible. And enable execution logging and actually look at it. Set up monitoring for anything unusual, unexpected child processes spawning outbound connections to addresses you don't recognize. The logs won't lie, but only if someone is reading them. And that's all 5. So, here's a quick recap of what we covered. Overprivileged tool access, no exploit needed, just bad defaults at build time. Denial of wallet, your budget quietly draining with no security alert in sight. Prompt injection, instructions hiding in plain sight inside data your agent trusts. Memory poisoning and leakage, attacks that survive a restart and spread like a worm. And credential theft and pipeline hijacking, the hardest to detect and the most damaging. The through line across all of these is the same thing that makes N8N so powerful in the first place. It's connected to everything, and when you're connected to everything, a vulnerability anywhere is basically a vulnerability everywhere. This kind of reminds me of the thing that's happening with OpenClaw right now. Well, N8N is almost just as powerful. That's why you need to be careful. If you found this useful, hit the like button and subscribe. And if you're actively building on N8N, drop a comment. I'd love to know what you're working on and what security questions you're running into. See you in the next one.